Hello there, Math 1B. I've got a new video for you. I'm going to go over the odd-numbered solutions to the quiz review that I gave you guys today. So, it'd be really helpful if you guys use this video as a study tool. Make sure you have all the odd-numbered answers correct and fill out the even ones. Get those turned in by tomorrow night. Let's get to it. So starting with number 1. So the very first lesson we did was determining whether or not a given expression is a polynomial or not. So I've got 4 different expressions. First one, 4y to the 4th divided by, here I'll write it a little bit larger so you guys at home can see better. 4y to the 4th over 9x squared. This is not a polynomial because variables on the bottom are a no-no. No variables in the denominator allowed of a fraction. That's always a deal breaker for polynomials. Letter B, yes or no? Yes, no variables in the denominators, nor are there negative exponents. How about 4/5 x minus 4x cubed? Well, it does have a fraction, but in the fraction, there's no variable in the denominator itself. So this one is also a yes. Part D, 4a to the 3b to the negative 6. This is a no, because negative exponents are not allowed in polynomials. Negative exponents aren't allowed. Negative exponents. Wait, I just said negative exponents. With polynomials, that's what I mean. All right, number 3. Number 3 is we're given a polynomial and we are asked to put it in standard form. Again, this is from the first video I did. Standard form means put the highest degree first. Highest degree first. So this part here has degree 3 because of the y cubed. This has degree 3 plus 2, degree 5. This has 2 plus 2, 4. So you put negative 3x cubed y squared first. Biggest degree goes first. Then we move on to plus x squared y squared because it has degree 4, and then plus 6y cubed. That's what it means to be in standard form. The leading coefficient is the first coefficient once you have it in standard form. It'd be negative 3. And for the degree of a polynomial is the degree of the biggest term in the polynomial. So the biggest term is degree 5. That's going to be the degree of the whole polynomial. Let's check out number 5. Number 5 says create a binomial with a leading coefficient of 7 and a degree of 3. Well, a binomial means a 2-term polynomial. They can't be simplified. So x plus y would be a binomial. But this binomial has to have a leading coefficient of 7. And a degree of 3. So I can make this x cubed. Now it has degree 3. Now it has a leading coefficient of 7. There's 2 terms, so it's a binomial. It satisfies all 3 conditions. So there we are. That one works. By the way, you could have done something else like 7x cubed plus 1. That works too. How about 7xyz plus 3? That works too. And so on and so forth. There's an infinite number of solutions for this one. All right, so this one's just simplify everything. Put it in standard form if you can. Number 7. All right, we got a lot going on here. We've got parentheses, and then a minus set of parentheses, minus set of parentheses. If you recall, I believe it's the second video that I made, 4.2. When you add or subtract polynomials, you have to look at the numbers in front. So I only got ones in front here. This is a -1. This is also a -1. Distributing a 1 to everybody changes nothing inside of here. So it's still going to be 1 times 8, 8, minus 1x squared minus 3x. Pretty much nothing changed when you multiplied by 1. For the second part, you're multiplying by a -1. -1 times 3x squared is -3x squared. -1 times -4x now becomes positive 4x. -1 times 2 is going to be -2. And then last one, again, you're taking everything inside here times a -1. You get -9x, -2x squared. -1 times -3 is positive 3. Now, it said put them in standard form, so my x squareds are the ones that should probably lead this thing off. So I've got a -2x squared minus 1x squared. That's going to be minus 3x squared minus 3 more x squared. That's going to come out to be -6x squared. Standard form means the x terms are going to come next before the constants. So I'm going to take -3x plus 4x. A -3 plus 4 is going to be positive 1. Positive 1 minus 9x is going to be -8x. And again, you can check that on your calculator if you can't do all that math mentally. All right, last one. 8 minus 2. That'd be positive 6 plus 3. 9. So, there's my final answer. -6x squared minus 8x plus 9. It's got a leading coefficient of 6, -6, and then a degree of 2. Let's check out number 9 together. This one's kind of like this one, but it escalated kind of quickly. You've got an xy on the outside of parentheses, a y on the outside of parentheses. This one's going to require a little bit more involvement. When you take 3xy times x squared, the coefficient's going to be 3. It's x times x squared, so now it's going to be x to the third power, and then there's going to be a y right there. Multiply it again by the -3y. 3 times -3 is -9. There's just one x, but now there's 2 y's. All right, now you take 5y times 2x, it's going to be 10, positive 10. Yx. Now, I think it's better to, instead of write yx, let's just write it xy. You're allowed to do that. Then you take positive 5 times -5. That's -25. Y times y squared is going to be y to the third power. Then you got positive 5 times -3. That's going to be -15. There's going to be a y there, but also an x cubed. So it's x cubed y. And then there's just a plus 10y cubed chilling out at the tail end of this. All right, so the question is, can we combine any like terms? The answer, yes, we can. X cubed y matches with x cubed y. 3 minus 15 is -12. x cubed y. You do not change the variable expression through adding or subtracting. Y cubed and y cubed, these two can combine using addition or subtraction. Negative 15, y to the third power. Now, it might be tempting to want to combine these two, but since this is x, y, y, and this is just x, y, they don't even have the same number of variables. They don't have the same degree. So you can't combine the two with addition or subtraction. Your job at this point is to just put minus 9xy squared plus 10xy at the tail end of this thing. It cannot be combined any further. So you're done there. Check out 11. If you'll notice, there's no plus or minus between the parentheses. That means multiplication is implied. So this is one of those situations where we say, you've got one of the binomials in one color, the other binomial in a different. We're multiplying all the green 7x's times all the purple 7x minus 4y's. Then we're going to take the positive green 4y multiplied by the 7x minus 4y. This gives you 49x squared. 7 times negative 4 is minus 28. X times y is xy. Then you take 4y times 7x. 4 times 7 is positive 28. Y times x is the same as x times y. And then you're going to take 4 times negative 4, which is minus 16. Y times y is y squared. Now hopefully you noticed from the get-go that these were good twin, bad twin multiplications, which almost always, no, not almost always results in the middle canceling. Negative 28xy plus 28xy is 0xy. And there's our final answer. All right, I believe this is the last odd problem on the assignment. So if you've made it this far, just stick with me one problem further. As you can see, there's no plus or minus in between the parentheses. So this is another situation of put one color, one of the polynomials in one color, the other polynomial in a different color. So I'm going to do green polynomial times purple polynomial. And then everybody in green is going to be put side by side with everybody in purple. So the green 4x squared, everybody in purple. The green minus x times everybody in purple. And then the green positive 1 is going to be multiplied by everybody in purple as well. So it's a distributive property bonanza. Now it's just a matter of organizing yourself so you don't get lost in a sea of letters and numbers. 4x squared times x, we're just putting another x on here, so it's 4x cubed. 4x squared times negative 7x squared is going to be negative 28 x to the 4 power. 4x squared times positive 2 is 8x squared. And our first polynomial, complete. Second polynomial I'm going to do in another color, just to show that there's a difference. A negative x times x is going to be a negative, and I'm going to put a 1 in front so that we know there's a number attached to it. Negative 1x squared. Negative x times negative 7 is going to be positive 7. X times x squared is x cubed. And then you got the negative 2 times negative x times positive 2 is negative 2x. And then, I'll do another color just to keep this thing rolling along. Oh, you're taking positive 1 times everything? Positive 1 doesn't change anything when you multiply, so it's going to be positive 1x minus 7x squared, since it's just 1 times it, and then 1 times 2 is positive 2. All right, nobody can combine with the 28x to the 4, so I'm going to just lead it off here. Our final answer is going to start out with negative 28x to the 4 power. Now the cubes should be next, so 4x cubed plus 7x cubed should be positive 11x cubed. Notice when I add these together, I don't get x to the 6 power. I keep x cubed. Let's see, who's next? The x squareds. So I'll put a diamond around it. 8x squared minus 1x squared is 7x squared. 7x squared minus 7x squared is 0x squared. So if it's 0x squared, you're not going to include it at all. 0x squared, not included. All right. Now we're just down to negative 2x plus 1x. That's negative 1x. And there's a positive 2 hanging out at the tail end, so we got to include it. All right, guys, I hope this was helpful in preparing you for tomorrow's Open Notes quiz. Just make sure you do the evens and do them earnestly, right? To the best of your ability, hoping for correct answers, not just filling it out. All right. Email me if you have any questions. Thanks for watching.